Hi, I'm Amina. So, today we're going to talk about TLC. No, this is not tender loving care. This one got more chemistry than your ex. TLC is a quick, simple, and low-cost method to separate and identify stuff in a mixture. It is super useful. You get fast result, it's non-destructive, and it barely needs any equipment. Let's take a look how it looks like, shall we? But used for checking purity, identifying unknowns, and monitoring chemical reaction. Did you know TLC was invented in the 1930s by two Russian scientists? TLC works by separating compounds based on polarity. Polar ones stick and move slowly. Non-polar, they zoom up with a solvent. The plate is a stationary phase, usually silica gel. The liquid that moves is the mobile phase, a solvent. The solvent climbs by itself, carrying each compound at its own speed. That's capillary action.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Huzaini bin Hussein, matrix number 083555. Today I'm gonna talk about components of TLC setup and a little bit more about TLC plate and stationary phase. So here we have 5 components of TLC setup, which is TLC plate, stationary phase, mobile phase, sample, and developing chamber. Alright, we go on to the TLC plate and stationary phase. TLC plate, a flat plate coated with a thin layer 0.1 until 0.25 mm of absorbent material like silica gel and alumina on a backing like glass, plastic, or aluminum. Stationary phase, usually polar, silica or alumina. It retains polar compounds more strongly.
My name is Nurul Aina Tasha binti Jalal. My matric number is 081448. Today I will explain about the TLC detection method and application of TLC. First of all is TLC detection method, which is a visual detection and UV light detection. Visual detection in this method is a colored compound can be directly observed on the TLC plate. If the compound has a distinct color, it will appear as a colored spot against the usually colorless background of the plate. This method is particularly useful for compounds that have neutral color, such as pigment or dye. Second, UV light detection. Many organic compounds are colorless and cannot be seen with the naked eyes. Therefore, TLC utilizes ultraviolet light to detect this compound. The TLC plate is typically coated with a fluorescent material. When UV light is shown on the plate, areas containing compound that absorb UV light will appear as dark spot again as a fluorescent background. This allows for the detection of colorless compound. Next is application of TLC, which is have 2 points. First is detection of food additive. Second is assessing reaction purity. Detection of food additive is TLC is used to identify and quantify food additive, such as preservative, colorants, and flavor enhance by comparing the RF value of the spot obtained from food sample with those of non-standard. Analysts can determine the presence and concentration of this additive. Next is assessing reaction purity. TLC can help assess the purity of the reaction product. If the multiple spots are observed on the plate, TLC plate, it indicates the presence of impurities of byproduct. This information is crucial for optimizing reaction condition and improving yield.
As for my part, it is the advantages and limitations of thin layer chromatography. Let's start with the advantages. First and foremost, there is simplicity, which means it is very simple to use. It is very beginners friendly, straightforward because the methods and complex equipment are optional, and it's very suitable for fast checking classroom experiments. Second, it's very cost effective, which means it is very budget friendly, contains budget friendly materials such as TLC plates, reagents, and solvents. There is needless to use costly equipment such as HPLC or DC machines, which helps reducing at cost. The third, it is fast result. It only requires a few minutes until 30 minutes for it to gain the results. And it's very effective for real-time chemical purity checks and reaction monitoring. Fourth, it is very environmental friendly because it requires minimal solvents and reagents, which helps reduces hazardous waste. Fifth, it's the minimal sample preparations. It only requires a few microliter samples for analysis. It is very beneficial when working with real compounds. Last is flexibility, which contains a mobile phase and stationary phase. As for the mobile phase, variety of solvent can be used. As for the stationary phase, such as silica, gel, alumni, or cellulose can be used. It is very easily used, just like I mentioned, and because it's very easy on absorptions. On to the next slide, we have the limitations of TLC. First, we have low resolutions because it's not effective in separation with similar compounds, which is RF values, and sometimes it overlaps or contains smear spots. It is very difficult to recognize and distinguish between complex mixture. Second, it is unsuitable for volatile samples. It is also unsuitable for thermally unstable compounds. Some compounds may evaporate or degrade during the drying process. Third, which is the qualitative. Mostly on this TLC will tell you on what is present and not how much of each compound is on the sample. So, for the qualitative, requires extra equipment to contain the information that needed. And last, it has limited sensitivity. Visualization depends on staining or UV lights, which may not work for all compounds. So that's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh to everyone. My name is Adira Khaira binti Muhammad Faisal and my metric number is 083505. Today I'm going to give you a recap or a summary of today's slides. TLC is a widely used technique for rapid qualitative analysis relying on interaction between a stationary phase and a mobile phase, where it's to separate compound based on their polarity and affinity. Second, TLC play a crucial role in compound identification, purity assessment, and reaction monitoring, making it an essential tool in research, pharmaceutical, and industrial application. Other than that, TLC also offers several benefits, making it a preference technique in many fields. First, it's quick and cost-efficient, where it provides result in short time with minimal expenses. Second, it's minimal sample preparation, where it's very simple and very efficient process. Thirdly, it's versatile application used in drug analysis, food safety tests, and also natural product identification. Fourth, where it's RF value calculation, allowing a comparison with standard for efficient compound identification. This advantage make a TLC an essential tool in laboratories worldwide. Overall, TLC is a powerful, efficient, and widely used technique that continues to be indispensable in analytical chemistry. And lastly, I would like to give a heartfelt thank you to our lecturers and lab instructor for their guidance, expertise, and support throughout our learning process. And also special appreciation to our teammates for their collaboration and dedication in conducting this experiment together. Bye-bye.